how large can an ant colony grow? Think of one species of ant that has been helping humans with farming for over 1,000 years. Long before anyone thought of ants as biological pest control, farmers in Asia were deliberately managing weaver ants. These ants have been used in Chinese agriculture for at least 1,700 years. This natural method marked the first time in history that an insect was used to fight pests in farming. Even today, some farmers still use this exact technique, placing small colonies directly onto mango trees. This shows the practice isn't just a historical relic. It's a friendship between humans and insects that has lasted thousands of years. A single weaver ant colony can build a leaf shelter roughly the size of a basketball. And it does this by using the colony's own young as living glue. Instead of digging a nest underground, weaver ants climb trees and glue leaves together to build their nest. But here's the catch. Adult ants can't produce silk. So workers carry larvae that are nearly fully developed to the edges of the leaves and gently tap their heads. In response, the larvae secrete silk, weaving together surfaces that bind the leaves into place. The result? A waterproof, sturdy shelter. Using this method, the ants can keep expanding their nest until it reaches the size of a basketball, or even a beach ball. Some nests grow so large that extra chambers have to be built just to house everyone. Not every colony grows by adding more chambers. Some species grow by never stopping at all. While most of what's been mentioned so far involves colonies that expand by building permanent structures, a type of ant called army ants does the exact opposite. Instead of living in a fixed nest, they form temporary, living colonies, and they're constantly on the move. Because of this, their colony size isn't measured by how long their tunnels stretch, but by how many tens of thousands of ants can stay locked together in a single, moving mass. Thanks to this ability, they're one of the rare large insect societies on Earth that essentially carries its entire colony along with it wherever it goes. So, how large can an ant colony actually grow? Have you ever wondered how far the borders of a colony actually reach? The answer is far more complex and far harder to believe than most people would ever guess. Because the largest known ant network on Earth isn't a single nest that simply grew bigger over time. When researchers studied completely separate Argentine ant populations living in Europe, California, and Japan, they found something extraordinary. These ants were genetically and behaviorally part of one single global-scale megacolony. That means ants separated by oceans, who may never meet each other in their entire lives, still recognize one another as family instead of as enemies. It's as if these colonies erased their own borders entirely. Here's the strange part. Even inside this single megastructure, hidden divisions exist. Along a famous supercolony stretching 6,000 kilometers across the Mediterranean coast, researchers discovered 33 distinct populations. 30 of them belonged to one supercolony, while the rest belonged to an entirely separate megacolony. So, this seemingly unbroken empire on a map is, in reality, a patchwork of smaller kingdoms living side by side. And the ants we usually see on the surface, they make up only about 10 to 15% of the colony's total population. The remaining millions are working unseen, right beneath your feet. But the most striking part is just getting started. Scientists discovered that out of roughly 14,000 known ant species, only about 1% are capable of forming a supercolony, which means these megastructures aren't simply the result of ants running out of space, but a rare biological tool that nature developed in only a handful of species. In the past, one colony pushed this rarity to its absolute extreme. An underground city more than 1,000 years old that, at its peak, is estimated to have held 1.1 million queens and 306 million worker ants. This colony was abandoned entirely, for reasons still unknown. Scientists later poured concrete into the empty tunnels to preserve the structure, revealing a fossilized ghost city, complete with roads, highways, and garden chambers. Essentially, the ants own Pompeii. And right after that comes what might be the most surprising moment in this entire video. Researchers brought together Argentine ants collected from different continents. Normally, ants react to strangers from foreign colonies by fighting instantly. But these ants recognized one another and showed no aggression at all. A result so unusual, it convinced many scientists that these ants may all descend from a single common ancestor, one that has spread across the entire planet. Even the same species can behave completely differently depending on where it lives. Argentine ants act peacefully and cooperatively when they spread to new countries. But in their native South America, they only ever manage to form small colonies, almost as if leaving home is what unlocks their true potential. A queen ant, meanwhile, can outlive a pet dog several times over. In some species, queens live up to 30 years. Because workers are constantly replaced, and a new queen typically takes over before the old one dies. A healthy nest is considered nearly immortal, as long as it isn't disturbed from the outside. Which means the colony in your own backyard could theoretically be the very same unbroken lineage your grandmother once walked over years ago. Some colonies even run their own livestock operations underground, raising aphids the way humans raise cattle, milking them for their sugary honeydew, and occasionally consuming them directly as a protein source. A single colony, functioning as both a dairy farm and a slaughterhouse at the same time. But colony size isn't only about how many ants belong to one network. It's also about how fast that network can grow, and some species break records here too. A single fire ant queen can lay over 800 eggs in a single day, and a healthy colony can reach tens of thousands of workers within just a few months of being founded. That speed is part of why invasive ant species are so difficult to control once they establish themselves in a new environment. By the time anyone notices the colony, it may have already grown far larger than expected. There's also a hidden cost to growing this large. The bigger a supercolony becomes, the more it actually starts to resemble a single organism rather than a collection of individuals. Some researchers have compared megacolonies to a kind of superorganism, where no single ant matters, but the survival of the whole network does. This is part of why supercolonies can be so difficult to eliminate. Destroying one nest does almost nothing, because the colony's real strength was never in one location to begin with. It was spread out, redundant, and nearly impossible to fully wipe out. So, in the end, the answer to how large can an ant colony grow really comes down to where you decide to draw the border. Some colonies are measured in queens, some are measured in kilometers. Some are measured by how many ants can move together as a single living mass, never staying in one place long enough to be called a nest at all. And as it turns out, nature tends to keep those borders far more flexible than we ever imagined. If this made you look at the ground a little differently, you're not alone. Scientists are still discovering new supercolonies. Let me know in the comments which fact surprised you the most, and if you want more deep dives like this into the hidden world of insects, make sure to subscribe.